Hi everyone, welcome back to Math with Amala. Let's start a new part of your chapter. Number 3 of grade 10, pair of linear equations in two variables. Linear equations are the equations which are having the degree of the variable as 1. For example, x plus by equal to c, or you can write it like x plus by plus c equal to 0, where a comma b comma c are real numbers and a comma b not equal to 0. C can be 0. Each solution xy of the linear equation in two variables ax plus by plus c equal to 0 corresponds to a point on the line representing the equation and vice versa. That means this linear equations are having a graph of the form straight lines. The general form of a pair of linear equations in two variables x and y is a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. Here a1, b1, c1, a2, b2, c2 are all real numbers and the a1 square plus b1 square and a2 square plus b2 square is not equal to 0 anyways. The graphical representation of a linear equation in two variables is a straight line. As we have discussed before, it is a straight line when we represent it in the graph. There are some two kinds of representations of a linear equation, algebraic and graphical. So this will be asked in the question. You have a question here. The cost of 2 kg of apples and 1 kg of grapes on a day was found to be rupees 160. After a month, the cost of 4 kg of apples and 2 kg of grapes is rupees 300. Represent the situation algebraically and graphically. Here, you can take one variable or the unknown as x and the next unknown as y. The cost of 1 kg of apple is taken as x and cost of 1 kg of grapes is taken as y, and there are some also given in the rate format. Algebraic representation can be 2x plus y equal to 160 and 4x plus 2y equal to 300. You have got two equations. You can number them like 1 and 2, and this is the algebraic representation. In order to do the graphical representation, you can do you can do or draw a table which contains x and y, which gives values for the two kinds of pair of linear equations. Let's take the first one, 2x plus y equal to 160. In this, I'm giving some numbers like 50, 60, 70. Corresponding to the values of x, I'm getting some values like for y, 60, 40 and 20. Likewise, I'm finding the next set of numbers also. If I get 50 as x and y as 60, then the ordered pair is 50, 60. In the ordered pair, you can write 50, 60 and you can mark it over there. Then the next point is 60, 40, then 70, 20. And for the next line, 70, 10, 80, minus 10, 75, 0. Likewise, you can find two lines and give them the names also. And when you find that line, and give some arrow marks at the two ends also. Now you can see that these two lines are not touching at any point, which means they are going parallelly. So by this method, you have shown that this kind of lines are not meeting at any point and they are not having a particular solution. Graphical method of solution of a pair of linear equation. For that, you have to consider two kinds of or a pair of linear equations, and you have to compare the ratios a1 by a2, which is not equal to b1 by b2. That means its graphical representation will be intersecting lines. And also the algebraic interpretation will be like exactly one solution. In case of solution, or when we find the number of solution, it is only one solution, it is unique, and the type of the linear equation is consistent. Next one, compare the ratios for the next set, and if you are getting a1 by a2 equal to b1 by b2 equal to c1 by c2, then it is coincident lines. And if the last two pairs are not equal, then it is parallel lines. When in the coincident lines, you have many solutions, infinitely many solutions, because one line is lying completely on the other line and they are dependent also. If one is moving, the other also will be moving. Likewise, for the parallel lines, there are no solutions because they are not meeting at any of the point in the graph or the plane. Also, they are inconsistent. So we can have one more point here. A dependent pair of linear equations is always consistent. Dependent means it is consistent. That means they are having a continuity in between them. Next one, there we have an example. Check graphically whether the pair of equations x plus 3y equal to 6, comma 2x minus 3y equal to 12 is consistent. Solve graphically. So in order to be graphical, in order to be consistent, those pairs have to have the a1 by a2 not equal to b1 by b2. It is clear here, so it is a consistent statement or consistent equation. Hence, you can find the values for x and y in different equations using two tables like this. You will get the points like 0, 2, 6, 0 and 0, minus 4 and 3, minus 2. Draw the lines along with 2 points because we need only 2 points in order to draw a line. And with 1 point you can draw many lines or infinite lines. That's why we are finding at least 2 points here. Join them and name that line as the required linear equation. Likewise, you can continue and you will get that a0 to b60 is a point, are the points in x plus 3y equal to 6. Likewise, 0 minus 4 and 6, 0 are the points in 2x minus 3y equal to 12. Here, these two lines are meeting at the point b 6, 0. That means they are having a single solution. So hence it is consistent. After exercise 3.1, you can move to the algebraic methods of solving a pair of linear equations. Here we have two methods to solve. In this chapter, we first discussed what are linear equations, then a pair of linear equations and how to represent them algebraically and geometrically, then the consistency, inconsistency, like the number of solutions we have found. Now we are going to find what are the solutions using two methods, substitution and elimination. Let's move to the first method, substitution method. Substituting the value of one variable by expressing it in terms of the other variable to solve the pair of linear equations. This is the procedure that we are doing here. Well, let's move to the example. 7x minus 15y equal to 2, which is the first equation. X plus 2y equal to 3 is the second equation. Now you can take x plus 2y equal to 3, which is the second equation, and you can write x equal to 3 minus 2y. Substitute this in the first equation. Then you will get 7 into 3 minus 2y minus 15y equal to 2. Now you have got an equation which is completely in terms of y, and solve it by opening the brackets and distributing 21 minus 14y minus 15y equal to 2. Then you can group the like terms. Minus 29y is equal to 2 minus 21. Minus 29y is equal to minus 19. Then y is equal to 19 by 29. You can substitute this y value inside 2 and you will get x equal to 3 minus 2 into 19 by 29. That is 3 minus 38 by 29. By cross multiplication, you can do for 49 by 29. So the value for x is 49 by 29 and y is equal to 19 by 29. Solve using substitution method. X plus 2y minus 4 equal to 0, which is the first equation. 2x plus 4y minus 12 equal to 0 is the second equation. Now you can see that here in the first equation, x is standing alone. So you can give that x equal to 4 minus 2y. Now substitute this value in equation number 2. Then 2 into 4 minus 2y plus 4y minus 12 equal to 0. This gives minus 4 equal to 0. Actually, this is a false statement because minus 4 is not 0. Hence, the equations do not have a common solution, which means the graph is in parallel form. The two lines are in parallel to each other. The next method is elimination method. In this method, we eliminate one variable after making the terms equal. Let's move to the example. 2x plus 3y equal to 8 is the first one. 4x plus 6y equal to 7 is the second one. You can see that one variable or first equation is with the 2x and second equation is with the 4x. So you can multiply with the 2 on the first equation and you will get that the first term will be like 4x in both. So 4x plus 6y equal to 16, which is the third equation. Now you can subtract bigger constant equation minus lower constant equation. You will get it like 0 equal to 9. Here also this is a false statement. This implies that these two equations have no solution. That means x and y have no solution. That means there is no point of intersection. That is, these two lines are parallel to each other. If solution is there, that means intersection. Keep practicing and don't forget to follow this channel for more updates. Thank you all for watching the video. Please stay tuned for the upcoming parts of your classes.